Okay, ladies and gentlemen, we're back in the workshop laboratory and we're starting something very exciting today. We've talked about basic circuits, we've talked about DC electricity and AC or alternating current electricity, but we really don't know where alternating current electricity comes from. This comes from a chemical reaction in a battery, but alternating electricity always comes from an interaction between the electrons in a wire and a magnet. Now, if you recall from the last lesson, I was able to touch the battery and cause a current to go through the wire, and notice that the wire jumps out of the magnet. That's how a motor works. When we send current through a winding in a magnetic field inside the motor, then the motor can be made to turn. But the opposite thing also occurs, and that is if I take and wiggle this wire manually, I'm causing the electrons to move back and forth, and that's the principle of an AC or an alternating current generator. They go back and forth, back and forth. Now, a single wire does not create really enough current to be very useful. So in order to have a useful amount of current, you have to wind up a wire into the form of a coil, and then it's the coil that rotates in the magnetic field and the electrons move back and forth. In fact, you can't see inside of this, but this is an alternator out of a car, which is an AC generator, and it has a shaft, and as it turns, it's turning a coil of wire inside a magnetic field, and that generates a voltage that we can use to charge our battery. It's a bit more complicated than that, but that's the essential idea. Well, now we're going to go one step further in the science that we're talking about, and that is that you never get something for nothing. And there's a process that takes place when I touch this and that wire jumps out of there that's very important. And that is that the wire itself, as a result of the current flowing through it, is creating a magnetic field. And it's the magnetic field of the wire that is interacting with the magnetic field of the magnet. And there is a law called Lenz's law, L-E-N-Z, Lenz's law, that says that the direction of the magnetic field around the wire will always be in such a direction so as to oppose the magnet field that we have down here. So that's why we get something for nothing. We're always going to generate a current in the wire when we move it, but the direction of that current will be such that it creates a magnetic field that opposes the one that's there. There's a fabulous demonstration of that. I really love to do this. This is a little tiny magnet here. I'll come up closer so you can see what I've got. This is a little tiny magnet. It's very strong though. This is a piece of steel tubing, this is a piece of plastic tubing, and this is a piece of copper tubing. This magnet sticks strongly to the steel. It won't move at all. It doesn't stick to the plastic and it doesn't stick to the copper. Steel or iron is a magnetic material. Plastic and copper aren't, but copper is a very good conductor of electricity, and anytime I move this magnet around the copper, I'm generating small currents inside the copper. So here's the fun and fabulous demonstration. This is so exciting because if I put these here and I try to drop the magnet into the steel, nothing will happen. It won't go at all. The magnet simply sticks to the steel and nothing happens. So we'll get rid of that. Now listen. When I drop it down the plastic, it falls quite rapidly. Let me do that again. Down the plastic, it falls rapidly. Now listen when I drop it down the copper. Took a long time. Now I'll hold it up. I'll hold the plastic and pay attention to the time that it takes to fall through here. This is an insulator. The moving magnetic field from the magnet does not create a current in the plastic. So it falls straight on through quickly. falls straight on through. There it is. Now look what happens if I try to send it through the same copper pipe that does have electrons that move. This is a conductor. And if I put it in here, I can easily put my hand down below and catch it, because the falling magnet creates a changing magnetic field, which creates a current in the copper tubing that creates its own magnetic field that opposes the cause producing it. The cause producing the current is this magnet falling. So the copper tubing has a current in it that creates a magnetic field that pushes back up on the falling magnet. And I find that fascinating. Here, the Lenz's law proof is absolute in that you never get something for nothing. The falling magnet creates a current in the copper current creates a magnetic field that opposes the falling of this object. And with that information, now we can go on and talk about how alternating current generators work and some of the dangers and hazards of that. This is video number 5 in the series on basic electricity.